So, hello to everybody. Welcome to our today's CIMAC Tech-Talk, and web event with the title eFuels, Turning the Tide for Sustainable Maritime Industry. This web event is organized by the CIMAC Greenhouse Gas Strategy Group. My name is Dirk Bergmann. I have the honor to be your moderator today, and I'm CTO for turbocharging at Turbo Systems Switzerland Limited, former ABB turbocharger. Short topic, or some words about our topic. In the Greenhouse Gas Strategy Group, we are observing and looking from engine manufacturers and users' perspective the legislation activities on greenhouse gas reduction and CO2 emission limitations. And within this, we come out with a recent position paper. We were elaborating on future marine e-fuels, and we are just working on other white papers to further evaluate, define what these fuels are. So today I'm very happy to have some experts of this group in here. But before we start, I would like to have some more introduction. The Tech Talks, we are just having this one today, is a new format for lively discussion. We want to offer a fresh insight into our current topics in the industry. We will have this discussion in a more informal environment. It will last roughly 60 to 90 minutes. And at the end, for sure, there will be also the opportunity for our audience to use the chat area to bring in some questions. This event will be recorded, so at the end you will find the record of this session at our website at CIMAC. CIMAC, this is the leading industry association that brings together large engine community and by extension the ship and the maritime industry together for scientific and technology exchange on common important topics. We are a global non-profit organization consisting of members from 27 countries worldwide with 11 working groups and 2 strategy groups. We are offering a forum to discuss on common issues affecting our industry. So before we start, some housekeeping about the rules. The audience can post their question as already mentioned in the chat. This will be taken during our Q&A round at, let me say, the last third of our panel discussion. We will try our best to answer as many questions as possible. As mentioned, the event is planned for a maximum of 90 minutes, will be recorded. And if what I think for today was not foreseen any presentations, we will also would be uploaded on the website. So now coming to our panelists. I'm very happy to have Jacob Sterling with us. He is Head of Decarbonisation, Innovation and Business Development at AP Moller-Maersk. We have in the call also Dorte Kubel. She is Regulatory Affairs Manager at MAN Energy Solutions. And Peter Müller-Baum, Managing Director of VDMA Engines and Systems, as well as for Power-to-X for Applications. And he's our CIMAC Secretary General. I would like to split our today's panel discussions in 2 main sections. We will start a bit about discussing in general about our recent published paper in terms of what's going on in our industry on decarbonization activities, legislation, and what are the main trends and drivers to do so. And finally, we will, in the second part, discuss a little bit more about what are these fuel types we might expect in our industry and what does it mean on a technical and on logistic and even for the operator side. To start our discussion, I will have a question for you, Peter. For your background from Power-to-X for Application, could you explain a little bit for us what are e-fuels And what do you expect of their availability over the next years to make our or make the fuel for our industry?
Yeah, thank you, Dirk, for that question, or for these two questions, actually. The first one is to be answered rather easily. The second one is a $1 million question in a sense. But let's start with the explanation. What are e-fuels? In principle, these e-fuels, so-called e-fuels, are synthetic fuels made out of hydrogen, preferably, of course, green hydrogen or climate neutral hydrogen, which can be produced by splitting water by using energy into hydrogen and oxygen. And the hydrogen can be combined by different processes depending on what you are going to produce, can be combined with carbon. And if you take that carbon out of the atmosphere, then you have a carbon neutral or climate neutral hydrocarbon, yeah, combination of hydrogen and carbon. And actually, that is from a chemical perspective exactly what you have when you are exploiting fossil fuels, any kind. So in that regard, with these kind of synthetic fuels, you are able to replace every kind of material what you are nowadays using on a fossil basis for any kind of propulsion. That is the easiest part of the easy part of the answer, because it just explained the technology, and the technology actually is rather old already. The electrolyzers to produce hydrogen is more than 200 years old, as far as I remember. And also the other processes are not really new. Of course, we have new developments nowadays, but we are not talking about rocket science. In principle, it's available, it's approved technically, and so on. Regarding the availability, we're talking about a complete different story. That's why I said the $1 million question. Because that depends, of course, on the market or the demand, and as long as we have fossil fuels available, which are definitely cheaper, and as long as those fossil fuels are allowed to be used, there is not really a market available for e-fuels, and therefore, by today, we don't see significant production sites everywhere in the world. We see a lot of pilot projects, a lot of official or public funded projects to see how it may work in future. But so far we don't see competitive production of e-fuels. I'm pretty sure that will change in future. When we may look at the end of that decade, so the late 2020s or early 2030s, I'm pretty sure that we will see significant amounts of e-fuel production worldwide. Because we see already now that the regulation is going to be changed, the market demand may change, not only due to regulation, but also due to customer requirements and so on and so on. But it's very difficult to say anything regarding the real availability then in 7, 8, 9 years. Again, technically, everything is possible.
Okay, thank you, Peter. Technically, everything is possible. Takes me to the next question. So, Dorte, from an engine manufacturer's perspective, what do you think about these e-fuels? Maybe staying with two-stroke engines for the first answer.
Thank you very much, Dirk, and thank you for inviting me. Yes, the two-stroke engines are already available to apply a number of these fuels that we were talking about here. And as Peter correctly mentioned, these types of fuel comes in both green versions and fossil versions, or what you may say. So, and the engine doesn't care, you can say, what is the nature of the molecule. So we can already now deliver engines that can operate on gas, on methanol. We are developing an engine capable of operating on ammonia, but with the caveat that these fuels are to some extent available in fossil versions today, but not yet in green versions. And yeah, as you say, everything is technically possible. We usually call the two-stroke engines an omnivore. It eats everything that we can make burn. So we are confident that we will be able to consume in the two-stroke engines more or less everything that could be brought to the market. At the moment, as I said, we have a number of different fuels that we see also the market is looking at and expect to be available. And all these engines are dual fuel engines, so they are also able to operate on normal diesel in case of lack of supply of these fuels.
Okay, thank you, Dorte. When you hear all of this, Jacob, as a representative of an international operating integrated transport and logistic company, I think you're operating something around 700 container vessels worldwide.
Yes.
What is your perspective on these kind of fuels and the whole decarbonization story?
Well, I mean, earlier this year we set ourselves a target that we would get to zero CO2 or zero greenhouse gas emissions, net zero by 2040 across our entire business, and with that, since most of our emissions comes from our shipping operation, that also means that we will need to go to net zero, of course, for the shipping operation. In 2030, we want to reach a point where we have halved the carbon intensity, so basically got in half the CO2 emitted per container moved, and that means that we need to continue our energy efficiency journey as we've done for decades, but the new thing is that we need to change to green fuels, because otherwise this will not be possible. We've also pledged that by 2030 we want 25% of our cargo to be transported by ships that run on green fuel, and that means that green fuels would have to make up around 6 million tons of our fuel supply. If it, for example, was methanol, which takes up twice the amount of space as the typical fuel oil. So that's a significant scale up, and we are looking at eFuels, but not only eFuels, we're also looking at biofuels or biomass-based fuels. Not only biodiesel, which is predominant today as a biofuel, we don't think that can scale enough, but also biomethanol. And if we look at those, I mean, we're making a big bet on methanol this year. We are building for the time being 13 vessels, dual fueled, to run on methanol, all from MAN. And we've said that all our future new buildings will also be dual fueled, and we think it will primarily be methanol in the coming years, because as Dorte also alluded to, there is no ammonia engine today, and even when the first engines come out, there'll be some years before we have a full catalog of engine sizes to fit our needs. So methanol is really, as we see it, the fuel that can scale in this decade, and we want to get started in this decade and have a real impact on our climate change impacts in this decade. So therefore we go for methanol. So biomethanol and e-methanol, and the way we see it is that biomethanol to start with is probably a little bit cheaper than e-methanol, because the technology, gasification and fermentation of biomass and synthesis into methanol is relatively well developed. Well, not well understood, I would say. It still needs massive scaling. But we would expect that over the years, biomethanol and other biotype fuels will actually begin to increase in price because they rely on biomass, and there will be a lot of competition for sustainable biomass. The eFuels, methanol and ammonia, will start out in the other end. It will start out high because right now electricity costs are on the high side, green electricity costs. We would expect those to go down. We also expect that electrolyzer costs will come down as electrolyzer production scales up. And I mean, there have never been so much attention to electrolyzer technology as there is now. So you would expect a technological development in that space as well, as we've seen in windmills and other green tech. So we expect that the price for e-methanol will have a relatively steep cost out over the next few decades. So, but nevertheless, we want to get started now, and we are talking to numerous suppliers, potential suppliers globally that can help us scale methanol, green methanol, both in the shape of biomethanol, but certainly also e-methanol. With the first agreement we made last year with a Danish company called Reintegrate, now owned by European Energy, that will make a plant, a green methanol plant, e-methanol, in southern Jutland, close to the German border, that will produce, I think 16,000 tons of e-methanol per year. That will be enough, or will be more than enough to fuel our first e-methanol fueled container ship, which will enter the water in next year sometime. So things are happening now, but the challenge is huge.
Okay, so here we have the first clear order of demand. Yeah, so thank you very much for elaborating on this, Jacob. I think later on we will a little bit more discuss about the fuel types. You already mentioned e-methanol and biomethanol. Before we start, I would like a little bit more to elaborate our current boundary conditions. As I heard from you, you already see yourself as a net zero carbon company in 2040. This is for me a huge statement, but on the other hand, this has to be, let me say, followed or even started with our legislation framework. So maybe Dorte or Peter from your side, where we are today with this. So we have the IMO for international shipping. We already have a legislation from IMO, which from my understanding, the limits are defined until 2026, something around. Which, how will it go on? So maybe Dorte, maybe Peter, if you're inside what is going on the legislation side to help the fuels getting into our markets.
Dorte, do you want to start?
Yeah, I could say something on the IMO framework. As you know, IMO has an initial greenhouse gas strategy with a goal to reduce CO2 emissions and to reduce the total CO2 emissions or GHG emissions with 50% in 2050. That strategy is about to be revised, and a large number of countries is in favor of having a more ambitious goal, but we will have to wait and see how that turns out. But one thing is having a goal. The next thing is having the actual regulation in place or systems in place to actually drive and achieve those goals. And IMO has agreed on a number of measures as steps towards implementing their strategy, so-called short-term measures, carbon intensity indicator and energy efficiency design index, both for new and existing ships. And so you can say there are some measures and some systems in place, but you see, that would need to be turned to achieve further towards decarbonisation, and certainly additional measures are needed, especially some kind of market-based measure to promote the uptake of fuels. These issues are under discussions in IMO. We see some movement, but there's also still some way to go. That's maybe a short introduction.
Okay,
So
thank you,
Peter.
Maybe Peter, you a little bit more on the European side. We heard already about the EU Fuel Maritime proposal. What is this exactly? Maybe compared to IMO, as I understood, there are some differences between those legislation initiatives. Maybe could give on some words, some thoughts about this, please.
Yeah, thank you, Dirk. Actually, the intended EU legislation at the moment, and first of all, the Fuel Maritime, but within the Fit for 55 package, there are also other regulations that may have an impact on shipping. The discussed ETS, for example, the European trade system for carbon dioxide emissions, also others. The situation in the EU is that the EU member states see the IMO discussion and the decisions as too slow, or consider that as too slow. Which is, by the way, also the opinion of a lot of shipping companies, but more and more also of a lot of shipping associations. Just a few days ago, I read an article from one of the big shipping associations saying the IMO target to reduce the CO2 emissions by 2050 by half should be already considered for 2030. Yeah? The problem with all that is, and actually I have to say I fully understand why IMO is that slow, but actually they are too slow. The problem is the investments for all that has to be done now, and not in 5 years, not in 10 years, but today. And to do any kind of investment, is it on the shipping side for new buildings? Is it on the production side for eFuels production? You need a clear legal framework in order to see that your investment is covered afterwards by the market situation. That means you need very clear signals that you are able to sell, for example, eFuels. And that is, from my point of view, that is the reason why the EU decided to pass the IMO and not to wait for an international agreement here. The problem we see with EU proposals is that they are not really consistent at the moment. There are clear signals that they want to have a much bigger ambition, much tighter targets, much earlier. But due to the fact that they have to deal with different regulations on European perspective, and that they have to find a way also to do it in line somehow with the international regulations we don't know yet, they created proposals which are not maybe the optimal way, to say it carefully. At the moment, these discussions in Brussels are ongoing. As you may imagine, we are here very much involved and try to find solutions which are able to give those clear signals. For example, a quota for eFuels, even if it's just very small, a quota for eFuels would allow the investors to start up with production projects. Just as one example. Yeah, we can talk about it later on in detail if you want to, but I guess that gives an impression already on the situation in Europe.
So the understanding from my point of view is quite clear that the legislations, let me say, are not quite consistent yet and not long lasting enough till 2050. And you also take into account the long lifetime of the vessels of about 40 years, meaning all ships going into operation now will still be on the waters in 2050, and therefore, for sure, and this was a good statement from my point of view, Peter, we have to make the boundary set up now to get this thing done. But on the other hand, taking this into account, saying, okay, it's quite uncertainty in the legislation framework. So, Jacob, I think it's very interesting from your company side to make these clear decisions. You are, let me say, a little bit ahead of the development. So can you give us some few words why you do this? Because at the end it means you have to pay more and you have to pay some extra. And at the moment I do not see any benefits that you have from your, as mentioned, 13 new builds for methanol. What is the background? The reason?
Yeah, I'm happy to elaborate on that. I mean, first of all, I actually think it's an obligation that we have as a big company to do what we can to fight climate change. Our company alone, our ships, the 700 ships that we have, emit 0.1% of the global CO2 emissions. So we have a responsibility to do something about that and to do it fast. I think that's the starting point. But then if we also look at our stakeholder landscape, our customers, our employees, our investors, just to name some of the really important ones in this context, we think this is also something we need to do. We don't think that we would be a relevant company in 10 years from now if we didn't take action now, regardless of what happens on the regulatory front. There's a lot of our customers who wants this, who are ready to pay for this, and who are already paying for it. We have a market, a product today, which we sell to customers where they get carbon neutral transport on the ships based on that we use biodiesel in the same amounts as needed to transport their containers. We see exponential growth in that product. It's not in the percentages yet, but it's picking up really fast, and it soon will be. And this is something that has happened over the last 2 years that quite frankly also surprised us. So even in a rate environment that we've seen over the past few years where because of the corona pandemic, rates have been record high, customers have still been willing to put something extra on top to get green fuels. So this is a very clear trend that we see with our customers. We think others experience it as well, but clearly that's a trend for us. The same for investors. Just to give you an example on that, we issued green bonds for the first time late last year. I think it was in November, based on that we would use the proceeds from these green bonds to invest in to help the investments in the vessels that we have ordered, the 12 big vessels that we have ordered. We issued bonds. We said we would issue bonds for $500 million. There was interest equivalent to $3.7 billion in these green bonds, which led to a record low interest rate for these bonds for us, which is very nice when we go into investments like this. And actually also, I mean, because yes, right now it's about scaling the fuel, and it's super hard, and it's going to be difficult, and it's going to be expensive and troublesome in so many ways. But if you think about it, to flip around actually the argument you made before, Dirk, around the lifetime of the ships, these ships that we order now will be in the water for the next 20 years. Do we believe that within the next 10 years, there will be regulation on CO2? Absolutely, yes. I mean, the IMO are slow. The EU is less slow, and maybe it's a little bit, as you said, Peter, the wrong way of attacking the problem because it's a global problem. But at least they're doing something. But what do we need to believe for it to be a good investment to buy dual fuel ships now? We need to believe that regulation will come, that investors will want this, that customers will want this. Everything is pointing in that direction. So for us, we feel when we spend, say, 10-15% more capex on these ships to get them with dual fuel capability, we consider it as an insurance premium that we pay to make sure that the vessels we order today are not ending up in the 30s being stranded assets that are useless to us. So even though they might go with on standard fuels for a couple of years before we scale up production, that's still fine because we know where we're heading, and it's much cheaper to get a dual fuel ship today than to retrofit it in 10 years. So that's really our thinking. We think that the train has long ago left the station for that any big company needs to address climate change. I know that maybe some companies are still standing on the station, but we think we need to get on this train and do it as fast as possible, and it's our obligation too.
Okay. Listen to you, it sounds to me that the industry now is setting the pace. Yeah. So it's very, very good statement. Thank you very much, Jacob. Dorte, from engine manufacturer's perspective, what do you think? When will you sell more engines with a decarbonized net zero carbon fuel running compared to heavy fuel oil or standard fossil fuels? Have you an idea?
I mean, we already see an uptake of dual fuel engines, also quite more than we actually had expected just a couple of years ago. Right now, it is primarily LNG engines, but we have customers like Maersk and others ordering also methanol engines. We have a huge interest in our coming ammonia engines as well. So we certainly see an interest in these dual fuel engines, and we talk now about different types of fuels, and we cannot point exactly which one will be the winner, but as Jacob says, we certainly also expect to see much more stringent regulation and requirements in the future, and we want to help our customers and make them able to use the green fuels when they are available. So in order to be future-proof, a fuel flexible engine is certainly a good idea and what we are promoting. We also do have the possibility to make retrofits for those who maybe are a little bit in doubt if they should board the train now or wait a little bit. So we are also developing such retrofit solutions that will be available.
For existing engines or for only new build engines?
For a segment of existing engines, the ones that are our MEC engines, so the electronically controlled engines, will typically be the ones that are able to be retrofitted and built in a more modular way. So the base engine is more or less the same, and then you have fuel equipment and of course all the tanks and fuel systems need to be adapted to the fuel.
Okay.
So we can also help some of those who may want to upgrade at a later stage.
And by the way, we might need that as well on top of the new builds. Who knows? To go fast enough.
And by the way, the turbochargers can also support this. Yeah, this is perfect.
Wonderful.
Yeah. Let's. We heard some fuels now. So methanol, ammonia, maybe even hydrogen. Maybe a little bit elaborate on this. Peter, from the association view, what do you think when you look at the maritime industry? Which fuels will we see? Will we have what will be the typical fuel type to substitute our current heavy fuel oil? Well, will there be one new fuel?
Again, a $1 million question. Thank you for that. I technically, to start with that, a lot of different kind of fuels would be possible, but I'm really in doubt that we see, I don't know, 10 or even more kind of fuels in future, because that will be too expensive to produce all these different fuels. On the other hand, I also in doubt that we just see one silver bullet. That won't happen. actually, I think we will see a competition between 2, 3, maybe 4 different fuels, depending on the region, depending on the distance you are dealing with as a ship operator, depending, of course, on the technology you prefer, but also on the application. Yeah, we may imagine that the container ship is using a different kind of fuel than a pleasure boat, for example, or even cruise liners. But my personal point of view is there are probably 3 major kinds we will see in future. That is, first of all, the methanol, what Jakob mentioned already, and he mentioned also the reasons why that is the case. So I don't need to repeat that. On the other hand, I see a future for ammonia. Although ammonia is toxic, and therefore we have, of course, to find technical solutions to deal with it in a very secure way. Ammonia from a production side will be cheaper than methanol, most probably. And in that regard, you may have a trade-off between the costs for the fuel on the one side and the cost for the infrastructure on the other side. So in that regard, I guess methanol and ammonia will have a future in shipping. The third fuel option might be the synthetic methane. And that is just for the reason because you see a lot of LNG orders nowadays. Of course, not a lot of orders with regard to the existing fleet, but nevertheless, yeah, the LNG market is developing with a lot of advantages for the current regulation, with the current requirements you need to fulfill. And if you have such a ship, you can easily switch it to synthetic methane. And maybe switch it depending on the technologies like retrofitting. You may switch it later on to ammonia. But first of all, with synthetic methane, and we have already existing projects here, you can use it. You could use the eFuel or the synthetic methane also as a drop-in fuel. This is, by the way, a very important topic we need to deal with as well, because so far we talked about the new buildings. Of course, we need to deal with the existing fleet in future, because otherwise we are not able to fulfill our climate targets. I'm not talking about the IMO targets, but in principle, yeah, the idea to be able to have a climate neutral economy by, is it 2045 or 2050? In that regard, we need to deal with the existing fleet as well, and that means we have to look also for drop-in fuels, because then you don't need to have you don't need to change anything regarding the propulsion system at all. Okay.
That is what is the engine manufacturer's view on this variety of fuels? You have to prove reliability. You have to make the certification. Maybe if you also can say your company also is selling 4-stroke engines, what does it mean for this part of the business?
Yeah, as the fuels that we have on our radar are the same that Peter just mentioned, and we are developing a little bit different, not different, but because we also expect that different segments may use different kinds of fuels, as you mentioned, some container shipping, which typically 2-stroke may use some other fuels. But we need, I think, for this at least until 2030, we need to look into these fuels. We may narrow it further down at some point, but at where we are now, we need to focus on those fuels that Peter has mentioned. We are also looking into hydrogen. It has some challenges, especially regarding the transport and storage, but it may be relevant in short shipping, for example. So we need to keep the things open and have a quite broad palette for the moment. It's challenging, but it's also, I mean, we are engineers, so it is also a very interesting challenge to deal with.
To be honest, very interesting times for being an engineer, by the way. Jacob, you have already mentioned that you already made your choice for methanol. Can you give us some insight about why you got there to go for this way, not taking ammonia or maybe hydrogen, or e-methane into account?
If I made it sound like, or if we have made it sound like we have made up our choice and we choose only methanol, then we have not communicated well. But we start with methanol because we can start with methanol now. That's really the message. We are also looking at ammonia, definitely. But as I said, before you can scale ammonia, you are towards the end of this decade. Whereas as for methanol, we can scale now. Hydrogen, even we're also looking at, but again, it's very difficult to store. It takes up a lot of space. But I think really with eFuels, we need to think about it this way. The feedstock from eFuels is electricity. So the more you can use electricity directly, as you do in an electric car, for example, the better. Obviously, for big ships, that's not possible, and especially not today. But the less you can do with it, the better, because every time you transform electricity into something else, you lose some of the energy in the process. So if you can, the first step is to make electricity into hydrogen. You lose some energy there, but if you can stop there, you really should. Maybe the trucks can stop there. Maybe some of the barges can stop there, right? But for long-haul shipping like ours, we need to get to something with that is easier to store and have a higher energy density, like ammonia and methanol. We don't think it makes sense to develop it all the way to a fuel oil type e-fuel. I think everything that we look at, that looks to be super expensive to go the last step towards diesel. Also, we think that e-methane is too difficult to make, and then you still have the problem with the methane slip, which you don't have for methanol. So for us, and that's really our analysis that leads us to primarily methanol and ammonia, but in the first instance, methanol.
So maybe to all three of you, when we now want to make a wish list to our legislators, to the politicians, what is needed now? So because as we said, we have the technology mainly ready. Let me say this for sure. We do need to be clear to also have the opportunity to get return on invest on the development work we have to do now, and we are still doing as an industry. On the other hand, you as a ship, as a fleet operator, are going to invest even in producing the fuels. But these are all costs, but still it's not mainstream, yeah. And as we learned, we have to convert the whole fleet until latest 2040, for example, or 2050. And maybe start now with all new boats to run on decarbonized or net zero fuel. So maybe in a round, I don't know who wants to answer first. Let's make up the wish list now to give some indications to politicians what we need on get this started. Yeah. Who volunteers?
I'm happy to start with, if I may. Actually, for the IMO, that is very easily to be answered. They need to speed up significantly. But to come to concrete proposals, I look again into the discussion in Brussels. And I mentioned before that the current proposals are not really consistent. On the other hand, or no, just to explain that a little bit, they have in the EU Fuel Maritime greenhouse gas reduction path, which ends up with a reduction of 75% in 2050 from my point of view, that doesn't make sense. I mean, of course, if you combine it with the IMO regulation, we may end up with 100% reduction. But as I mentioned already before, and what we need now are clear signals to break with a chicken and egg problem of investments here and there, and to end up with a 75% reduction of CO2 in 2050 is not a clear signal from my point of view. What would help from our opinion is a quota, for example, for eFuels, any kind of eFuels, yeah, and you may measure that by the greenhouse gas reduction, of course, but a clear quota right now, yeah, end of the 2020s already. That might be just a small amount because we need to develop the market ramp up, and as we discussed at the moment, there are no production sites yet apart from small pilot projects. But even with a small quota at the beginning, you will have that investment, and that is, from my point of view, the easiest way for the legislator to say that that is the way we want to see it, or the way to go. And just one sentence, sorry. If Europe start with such a proposal, I think also the discussion on at IMO level will speed up, because then you can see it would work if we start with that now.
Mm-hmm. Mm-hmm. Dorte, Jacob?
I can go. I mean, from our side, I mean, it's really all about creating a level playing field, or rather, we need to create a playing field where the green is cheaper than the black or the fossil. That's today it's the other way around, and therefore we need a mechanism, a carbon tax, or rather a CO2 equivalent tax that looks at all greenhouse gases, both the methane and the CO2 and the LAR, the NOx, what's it called? The Danish nitrous oxides that could come from ammonia engines. We need to have it all in there, all the greenhouse gas emissions that could come from these engines, and a life cycle perspective, of course, on that. But we need a level playing field. We need a carbon tax of some sort, ASAP. We also think that we should have a drop dead date, as we call it, for when would be legally allowed to commission a ship with a fossil only engine. So at some point when the green fuels are sufficiently scaled, why would it be legal to build a ship with a fossil only engine? This is inspired by what the EU is contemplating right now on combustion cars, where they say that from 2035 it would not be legal to buy a new car with a combustion engine. Of course, this could still be a combustion engine, but maybe it had to be a dual fuel engine or something like that. But it is really, when you think about it, the world is in a climate crisis, but the regulation is such that if you use the fuel that is polluting the planet and causing the crisis, then it's way cheaper than if you go for the green that does not. That is so counterintuitive and just really plain stupid when you think about it. So that needs to change, and that needs to change as soon as possible. It should not be an excuse for inaction from companies, I still believe. At least from our side, our analysis on what is actually the right thing to do for us will be to go this way regardless of regulation. But we do, of course, hope that regulation will come, and will come in strong, because it will actually change the competitive landscape and make it a good business to invest green, and that we actually think would be quite reasonable and in line with what the broader society would expect of us as a sector.
Mm-hmm.
Yeah, if many good points have been made, fully agree that first we need a clear political signal from IMO. As you said, we certainly prefer international regulation and an international level playing field for this. So clear political signal from IMO to go for zero in 2050, and as I said, to obtain that, we need these specific implementing measures, and one important element is certainly a market-based instrument like a carbon or CO2 equivalent tax or levy. It may be supplemented by some kind of fuel, low GHG fuel standard, which is in principle what the Fuel EU Maritime is, to promote the uptake of the green fuels. But that, of course, relies on the supply of these fuels. So we also rely on a political will to change and transfer the complete energy system to renewable fuels. So we also rely on all the states are taking action to green their complete energy systems in order to supply the fuels and the energy that we need for shipping. So there are a lot of elements that needs to come in place, and preferably from IMO. EU actions may, we see that primarily as a way of pushing IMO forward. And then there are also some, you can say, some enabling regulation, the safety regulation you mentioned, ammonia, the toxicity, hydrogen, but in that area we actually see quite much commitment from industry at the moment to start, or they are already developing classification societies, and so member states are already looking into these safety guidelines and safety codes. So there we certainly see a commitment to move this forwards and to have also the enabling safety regulation and so on in place.
Okay, so to sum that up, we urgently need the picture and the framework for 2050. And have this in place to get to set up the industry, to change the whole fleet, but also doing this on the other hand, looking at the intermediate measures. And I think Peter, you already mentioned drop-in as a possible intermediate measure. I think also Jacob, you mentioned biomass-based fuels. There are others like slow speeding or shaft power limitations. But even from my perspective and from our perspective as an industry, they are quite limited and not capable to make the whole step down to zero, net zero carbon emission. But maybe have a look at these intermediate steps. Are we ready to take them and to, let me say, moderate change the existing fleet? Not to zero, but to reduce by 20, 50, whatever %. Or do we need additional measures for this?
So are you addressing the question to anyone specific? I can speak to it if you want me to. I think that you're right. All these efficiency measures and also, I would say, transition fuels will not get us to zero, but they can play a role, right? I think for us, we intend to go from the engine type we have in our existing fleet today, so a regular two-stroke engine running on diesel, to dual fuel engine running on methanol, ammonia, or maybe something else in the future that hasn't been invented yet. Who knows? But we do think that drop-in fuels that can work in our existing fleet would actually be quite good. We have it as biodiesel today. We can also see that certain waste streams can be turned into diesel type fuels that could also be used in the future. And I think we should be open for that. Absolutely. We don't think we need an interim step. I mean, for us, it would be an interim step to go to an LNG engine and then go to a methanol engine later. We don't think we need that step. But but we do need to look at energy efficiency in a different way, because the price tag for the new fuels is going to be somewhat higher than what we have today. Maybe 2-3 times more expensive to start with. And that means that the business case for going a little bit slower or installing a new gadget on your ship or doing other things, that business case that changes. So things that came with a long payback before comes with a short payback in the new regime. So we will need to do our utmost to use as little as we can of the new fuels to get the job done. And that means that all the tools in the toolbox, and maybe some new ones on improving energy efficiency, remain relevant and get even more relevant in the future, simply because of cost. Because when you switch to, say, green methanol, yes, you're green, you're down to zero, but you still want to have a good cost also. And since the fuel is expensive, if you can use less of it, very good. So that's I think, but that's an optimization both on the technology side and on the operational side, where I think there's still quite a lot to be gained in this.
Yeah, if I can add, certainly we also see a need to have continued focus on energy efficiency and improving that also with the new fuels. It can get us some of the way, and the existing fuels like LNG can get us some of the way towards at least IMO's 2030 current 2030 goal. Would probably not require the use of zero carbon fuels, but we are certainly ready to deliver the solutions to also to go further than that. So certainly continued need for focus on both the fuels, but certainly also for the energy efficiency gadgets, as you call them.
Keep the cost down. Yeah.
I'm not a deep technical person. I'm not an engineer, so I use the word gadgets because that cover even the small ones and the really big ones and complicated ones. But there's a lot of them out there. And yeah. I think engineers like gadgets in general. Huh?
Peter, any thoughts from your side on drop-in?
Nothing to add what Dorte and Jakob said, actually.
Okay, before now open up the questions to what I see in the chat, questions to you three. Are there any points you want further to discuss? Any topics I didn't ask or discuss now? If not the case, so I will have a short look at what we see in the chat. Here's a question: what steps and system components of a large two-stroke diesel engine fuel supply systems need to be modified in order to convert this conventional engine and the supply system into methanol? Maybe Dorte from engine, maybe Jakob from your experience with the new builds. What are the technical changes we need to do on a two-stroke engine to get it run on methanol?
Yeah, as I would say, the fuel system and injection system needs to be updated. I'm not a specialist on fuel systems, so I cannot tell you exactly what valves and so on needs to be changed. But you're talking about the fuel supply system and the injection system, but we aim at developing it as a kind of a modular installation, but still retrofitting in service is not always it's possible, certainly, and we have done that in several cases, especially with LNG, but it can certainly also be done for methanol. But of course, it's easier to do it from for a new build engine.
Yeah, for sure, due to the lower energy density of methanol, the amount of fuel injected in the combustion chamber has to be increased for sure, and therefore all the system and the injection system has to be adapted from our point of view.
Yeah, and tanks and so on as well, of course. So
Yeah, and for sure.
Mm.
But Jacob, you are working on methanol, so new fueling stations in the harbors, right?
Well, yes, we don't know exactly where we need them yet because we don't know where we want to have these ships trading, and we don't know where the fuel is going to come from. So there's a lot of unknowns in this still, and that's just the nature of it. But yes, we will need a new, you can say, a methanol bunkering setup. It's nothing new as such. If you speak to the likes of Methanex or Proman, they know how to do this, and it can be done. But it's more about setting up the infrastructure, of course. On the ship, as was alluded to, I mean, methanol is a low flash point fuel, which means that there needs to be a lot of different safety measures for methanol. The tank is roughly twice the size, and there are also some safety measures around the tanks and what have you. So it is quite very different on the fuel system side. Whereas what I understand from the engineers that if you look at the engine, then you need to be a specialist to distinguish between a regular engine and a methanol dual fuel engine. They look quite the same, but of course, whereas a normal one would have, as I understand it, three injections, then on this one you would have 6 because you would have 3 for the diesel and 3 for the methanol. But yeah, that's also how deep I can go, more or less, on the technical side. But you're right, the infrastructure will be challenging, and especially in the beginning, because I mean, just to give you a very practical example, we have ordered this methanol fueled feeder vessel, so a small container ship that will be trading in Northern Europe from mid next year, and it's going on a fixed route, as the container ships do, between, say, northern Germany and St. Petersburg. And we then need to set up somewhere along that route where this ship can be bunkered with the methanol that will come from southern Jutland in Denmark. And how is it that we convince someone to bring a barge to a port on that route once per month when a ship comes by that needs the fuel? I mean, that's the tricky part, right? Whereas for most other bunkering companies, they have a lot more customers than that in a particular port. So we will need to be quite creative here in the beginning, and it will probably also be more expensive. But the good thing for container ships is, and that goes for the feeder as well as the big ones that we have ordered, we have designed the tanks so that they can bunker once and then do a round trip and come back. So that means that at least to start with, we just need for the feeder we need 1 bunker station. For the big ones, we also need one port where we can bunker, and that makes it easier to get started. Whereas I think for bulkers and tankers, it's harder because whereas we run our ships as like a bus service on the same route all the time, so we know when we come back again. Then for the tankers and the bulkers, the dry bulk, they run more like a taxi service, so they really don't know where the next job is. So they would need a lot more assurance, if you will, on methanol supply. But yeah, that's I think are my main points on this one.
You just mentioned you designed the tank system for a complete round trip. Do you need to reduce the container capacity for increasing storage capacity? Can you give us some insight on this?
Yes, you will have to do that because you still need a fuel tank of a certain size, maybe not for a full round trip, and then a fuel tank for the methanol. So you will take out some cargo space, but actually I would say I was surprised that it wasn't more. I mean, I cannot go into more details on that, or then I will be that some of the people inside would not like that, but I was actually surprised that it wasn't more. So I don't think it's detrimental for the vessel economy overall that you have this fuel tank because there's still plenty of space for cargo.
Okay. Here got another question. Considering the IMO initial strategy target for 40% CO2 reduction per transport work by the year 2030. From an engine manufacturer's perspective, are dual fuel engines reliable, safe, and economically available to cater for possible depends within this time framework? So exactly how prepared is this technology to meet this target? So say, okay, we are going to shift, we need to shift and to reduce by 40%. Is our fleet already ready to do? Dorte, do you have any idea on this?
As I said, with the current predictions and what the fleet has obtained, because it must be remembered that the reduction targets are compared to 2008. It seems like the 40% reduction goal can be obtained by a combination of technical energy efficiency measures, dual fuel, primarily LNG, and also route optimization, slow steaming, operational measures. That is what we see. As I said, it's not that we couldn't deliver something that could do better, but that's the current target. I don't know if I can add one point, which I wouldn't say I forgot, but we talked about a lot about these new fuels and how we get them onto the market. How do we get the new or the ships with ready for methanol, ammonia, and so on. And one issue which is also built into this Fuel EU Maritime is the possibility for to look at a fleet instead of a single ship. IMO traditionally, and that makes sense because IMO usually regulates technical issue. They look at a single ship, and this single ship has to comply. But for GHG reduction measures, it could make sense to look at a fleet instead of a single ship in order to phase in requirements that would give some more flexibility to fleets in case of older ships being phased out in a short time. They may not need to be updated, and you could make for example, a smaller number of ammonia or methanol ships as your first step. So it's also a way of incentivizing first movers. So just a comment on that. Realizing it's not straightforward, but at least it's an element for consideration in the legal framework that we think is worth considering.
Fully sure. Thank you very much for this comment, Dirk, because this is also part of our position paper that we need these fleet-orientated balancing to have the opportunity to incentivize first movers and innovative companies like Maersk, who take the risk introducing new technologies and introducing new fuels for their businesses. Yeah, another interesting question. What about carbon capture on board? Any ideas about this?
Yeah, I mean, I think it's if you take methanol, we've talked a lot about methanol. To produce methanol, e-methanol, you need CO2 and you need green electricity, and the CO2 needs to be biogenic. We think that at some point that will actually become a limitation to get good access to cheap CO2. Right now, there's plenty of it from pulp and paper plants and from biomass-fired power plants, things like that. But the thought that you could actually run a ship on green methanol and then capture at least some of that CO2 that would otherwise go out of the chimney and actually bring it back to produce new green methanol, new e-methanol. I think it might be a little bit of a science fiction idea, but I really think we need to stay open even for those ideas in the challenge that we have, because the economics might actually be favorable at some point. So I wouldn't say we're looking at it very actively, but we are following this field very closely, because there is a chimney right there on the ship that emits a lot of CO2. Why let it go if you need it to produce fuel? But there's a ton of complications around it, of course. But I can see, Dirk, that your inner engineer is already now thinking this would be even more exciting. Yeah?
But I'm still thinking about cargo capacity, and then somewhere you have to store the CO2 on board the ship to bring it back to the e-methane facility. Yeah? Maybe it's better to have it on land and more technically feasible. But yeah, I'm with you. Yeah. In terms of a little bit,
imagine you could have some tanks where you could actually pump the CO2 back into the tank or something. I don't know. There's a ton of question marks around this still, but the concept should be looked at with an open mind, I think, because maybe it could be something. I mean, I personally think that as an industry, we will have to be in innovation mode for the next 20 years, maybe longer, to not only develop this new world of fuels and technologies, but also continuously optimize it and refine it, because it's as you said in the beginning, Peter, who knows what the fuel mix will be in 2040. I mean, I would certainly not say that we do, and I don't think anybody does. There's so many moving parts, both on the production side, the infrastructure side, the use of the fuel side, and the regulatory side even, right? So it'll be interesting, if nothing else.
In that regard, Jakob, because I fully agree with what you said. Also, the description of that, it sounds more than science fiction than to be a realistic chance at the moment. However, we don't know what happens in future, and typically these kind of transitions, which are forced to develop also new technologies, typically lead to new ideas you can't imagine 10 years ago. Yeah. So what we really should do is to create a legal framework which allows these kind of technological developments. In that regard, and again, that is something Jakob mentioned beforehand, market-based measure, also Dorte mentioned that market-based measures, are the easiest way to achieve that. Yeah? If you are dealing with the bits and pieces from a legislator's side, you may come up with good solutions on short notice, but on the long run, it's much better to give a clear legal framework which allows also to develop things you don't know yet.
Sorry.
No, please go. Yeah.
No, just fully agree, and it seems like carbon capture technology is also speeding up in the stationary industry, and it's of course something that we are also keeping an eye on, and it could be interesting, but of course there needs to be a clear legal framework, especially in the case where you would want to have carbon capture and storage to be sure that this carbon is actually stored, or can we have some kind of carbon cycle, all interested ideas, and that's why, as Peter mentioned, we need the technology or the regulation to be technology neutral, and in order to foster all kinds of ideas and have the most efficient solutions.
Here's another question that goes a little bit also in the direction of legislation. So the question is, how are we going to ensure uniform availability of alternative fuels across the regions, even globally? Yeah, I think it's a fully must to do so. Maybe from my point of view, it has to be part of legislation. I think their IMO would be the best body, maybe, or international standard organization to set up this. On the other hand, from my point of view, these are quite simple chemical molecules compared to heavy fuel oil. So it might be a little bit easier to set standards for these fuels, but for sure, it is absolutely necessary to do so, right?
Yeah, but I think it's also something that the market will do. I mean, when the rules are there and when the demand is there. If we just, we actually had a pretty successful exercise in the industry a couple of years back when we switched from high sulfur to low sulfur fuel. And yes, it was a ton of preparation in getting that done and so forth. but it did actually. I mean, if you look back at it now, it actually happened relatively seamlessly. I mean, there was a few incidents here and there, but they would probably have happened anyway. There was just more focus on them. But actually, we managed to make a massive switch in a very short time. Of course, it was from one fossil type to the next, but in terms of the infrastructure, I think that's probably where we are the most agile. But the regulation needs to be there so that it's clear that it makes sense to do, and all the market demand needs to be there to make it so that people are assured that this is something that needs to happen.
Yes,
that's my take.
Yeah, a good example of a clear signal, and because the IMO regulation does not actually demand for the fuel suppliers to make the fuel available, but there was a clear signal, and then the fuels were made available globally. Of course, this is another type of transition, but as an example, I agree that it gives an indication that with the correct signals and the correct lead times, it's possible.
Here's a more economy-based question. When looking at e-fuel engines and get them introduced into market, what would be more important? The capex, so the investment side, or the operation side, so at the end fuel costs? What do you think is the most important driver on an economic base, especially even when we're looking at different fuel types? Or is it just done by legislation?
Yeah, I mean, it's not that the dual fuel engines are over the top more expensive as the conventional engine, 10-20%. So I think it's very much about the operational costs, and also on the availability and the level playing field.
Yeah, I would agree. I mean, for in the lifetime of the ship, it's definitely the OPEX that will matter the most. I think that, but on the other hand, you know, from a decision point of view, the investment decision point of view, I think that for us at least, it's been relatively easy now that we believe in this future to start investing in dual fuel engines, dual fuel ships, because they are not that much more expensive, and yeah, but then we just need to get the fuel, and we need to get the price for the fuel down, either by market or by regulation or by both.
Peter, any idea? Or I don't know if you
just I agree with Dorte and Jakob. Maybe just one additional comment. I guess the OPEX are more relevant, but again, the different question, or the difficult question, is how energy cost will develop in future. From my point of view, considering that we will see carbon taxes, carbon pricing somehow in future worldwide, energy costs are getting more expensive, and in that regard, OPEX will become even more relevant.
Another question is here on methane slip. How can we, or how will we address methane slip? Will there be any regulations upcoming? Peter?
Short answer is for sure they will, for sure. I can't imagine that won't be regulated actually at international level. There might be first movers in Europe, in the US, I don't know, but they will come. And actually that is the reason, that is one point where I disagree with Jakob slightly regarding the e-methane, because I'm pretty sure that regulation will come, and we will see the technological solutions available to deal with that. And actually, if we're talking about synthetic e-methane, the methane emissions in the supply chain are very low, yeah, because typically you have it now when exploiting gas and so on. However, you need to deal with that for the engine. And for two-strokes engine, the solutions are already available in the market right now. For four-stroke, not yet, but technically possible. So I'm very sure about that topic.
Yeah,
and I think from please go. Yeah.
Oh, sorry. Yeah, actually, already the Fuel EU Maritime proposal from the EU Commission does not directly limit methane slip, but it incentivizes engines with low methane slip, as it is a GHG well-to-wake based proposals. So with that, we actually already or will have when this we expect that to enter into force, we will have there the first driver to reduce the methane slip, and we expect IMO to introduce some kind of similar approach. And as you mentioned, Peter, the technology is there, and I heard once an EU Commission representative say that regulation is an excellent technology driver. So when these things are in place, we will again see these engineers rush to solve this and other issues as well that may also be other emissions we may have for alternative fuels.
Just one comment on e-methane part, because I actually agree with you what you say, Peter, that of course if you do e-methane you will have much less supply chain slip, and if you then use the right engine and all of that, you can also reduce the slip quite a lot, almost down to zero. But if you have a hydrogen, it's just hard for me to see why you would turn that into e-methane to get a gas that is hard to handle, because you do need the carbon anyway to make the e-methane. Why then not make a methanol that is a lot more easy to handle and where you get rid of all those? Of course, if you already have a fleet of LNG ships, it's a different story. Then this could be one of your pathways to get to zero. But for us, where we have not invested in LNG ships, that would be for us an odd choice to make. Then the methanol choice is a much more straightforward. But I think, I mean, quite honestly, I think that it's great that we see the different bets on different fuel technologies, because as we said many times on this call, we don't know where this is going to end, and we need to experiment a lot to find out what are the right solutions under which circumstances for which ships and so forth.
Okay, thank you very much. One point we haven't tackled yet. It's this well-to-wake approach we also discussed in our position paper, saying that we have to take this for sure into account where the fuel coming from. Taking, for example, ammonia having no carbon atom inside, and therefore just burning it will be a zero carbon fuel. But at the moment it's produced by natural gas, and then shifting completely to ammonia at the moment would be a disaster on the climate point of view. Yeah? And the same with the methane slip. I think as soon as we get into the situation from well to wake, we will also need to take into account the logistics and all the methane disappearing during transport, and therefore we have the best way to balance this out. So fully agree to it. Yeah. So I just see there are no further questions in the chat. So this leaves us, we have roughly 6 minutes at least to go, but we do not need to fully extend to this. So if you have any further things you want to mention at the end, but I think we captured nearly all of this. So I got a little bit through our position paper. We have addressed nearly everything. So if there are no further comments from your side, thank you very much.
Just a full support for the urgent need for having these well-to-wake approach in place, especially in IMO, and we really hope for some action on this item from IMO this spring. So just a final note on that.
Thanks for clarification, Dorte. Thank you very much. Yeah. Okay, so then it leaves me just one quick, no further questions. So thank you three very much for taking part in this panel discussion. I really enjoyed it. I think we brought up some very interesting point to our audience, which I also would like to thank you to participate, to listen, to ask questions. So and just to the audience, if there are any other questions coming up, please feel free to contact us via our CIMAC website. We will then take them up and will for sure give an answer for this. So again, thanks a lot. Have a nice rest of the day, night, or whatever time zone you are, and a relaxing weekend to come. Thanks again, and bye-bye.
Thank you.
Well, thank you. Yeah, have a good weekend all.
You too.
Thanks a lot. Bye-bye. Take care.
You too.